Okay, so now I want to show you a really powerful application of determinants. In fact, I think you'll really get a kick out of this because it's going to show you that a lot of the hard labor that we've been put through actually, in some sense, is for naught if you know determinants. So this is actually referred to as Cramer's rule. And Cramer's rule is a means of using determinants to actually solve systems of linear equations when you have the same number of equations as you do variables. So if you have 2 equations and 2 unknowns, or 3 equations and 3 unknowns, or even 4 equations and 4 unknowns, or 57 equations and 57 unknowns, you can always solve that system, if it's solvable, using Cramer's rule. Just a way of using determinants to find the answers. So let me actually show you how this works because it's so cool. Let me write down a general, just 2 by 2 system of linear equations. So I'm going to put in coefficients here, but they really are supposed to be numbers, okay? So I'll put a1x plus b1y equals c1. Now, don't get freaked out by this. The a1, the b1, and the c1, they're just some numbers. They're the coefficients that would sort of go there. I'm just trying to show you the formula in general. So there you have a1, b1, c1. Now, the next equation, let's call those coefficients. They'll probably be different. a2x plus b2y equals c2. Okay, so there's the second equation. So if I have 2 equations in 2 unknowns, here's a really cool way to find out what x and y equals. The first thing you do is you create 3 determinants. The first determinant, which I'll just call d, that will be the determinant, so I'll use the determinant symbol, of the 2 by 2 matrix I get by just looking at these coefficients. So basically just lopping off the x and the y and looking at a1, b1, a2, b2. So I just lop off those coefficients and make a 2 by 2 matrix, take the determinant, and I call that D. Okay. Now the method I'm going to show you only will work when this number is not 0. So this has to be not 0, otherwise Cramer's rule is not going to work. So in particular, this matrix has to be non-singular. Remember, non-singular just means the determinant is non-zero. So if that determinant is not 0, you can press forward with this method. If the determinant equals 0, then in fact this method won't work, and you'll see why in a moment. Anyway, there's the first determinant I want you to compute. The second determinant I want you to compute is the following. I'm going to call it d sub x. And it's still a 2 by 2 matrix, and here's the recipe, and here's why it's called sub x. You take these terms here, or these terms here, in the x column, and you remove them, and instead insert these 2 things. So you take what's in the x column, remove them, and replace them by these numbers here on the right-hand side. You put them in, and I'd see c1, b1, c2, b2. Do you see that d sub x is just what I got here, but I remove the x column and replace it by these numbers? That's all there is to it. And then the last thing I'm going to find is going to be d sub y, and I bet you can figure out what that is. It's the analogous thing. I go back to here, but in place of the y column, I put these in. So I have a1, c1, a2, c2. So now I've got 3 numbers. I've got this number, and that number. And you want to know what? If you want to find out what the x answer is to the original system, you just take dx and divide it by d. That's the answer. If you want to find out what y equals to this whole system, you just take dy and divide it by d. Isn't that amazing? So all you have to do is compute 3 little determinants, and you get the answer. No more substituting and elimination of variables and It's real easy now. It's just this. Now, you'll see why the d can't be 0. Do you see it? Because then I'd be dividing by 0. So this only works when d is not 0. Let's try an example and see this thing in action. So let's use Cramer's rule to solve the following. 5x plus 7y equals minus 1. And 6x plus 8y equals 1. Now you can use a substitution method, an elimination method, or all these other methods we talked about, but let's use Cramer's rule and see what happens. So I have to compute a few things. First I'll compute the determinant d. That's the determinant of just the coefficients. So 5, 7, 6, 8. So let's see what we get here. So I take 5 times 8, which is 40. and then I subtract off 7 times 6, which is 48. So what's 40 minus 48? Well, it's negative 8. So in fact, I see that this determinant equals negative 8. Okay, so that's that. Is it 0? No, it's not 0. This is non-singular, so I'm okay. So let's keep going. Now let's compute d sub x. How do I compute d sub x? I just take this matrix, but get rid of the x column in exchange for putting these numbers in. So I put in minus 1, 1 in this column, but I keep the other column the same. Now I compute that determinant. Well, that's minus 1 times 8. So that's just minus 8. Minus, and then 7 times 1. So what's that? Well, minus 8 minus 7 is actually going to be minus 15. Cool. One last one, d sub y. Notice that these things aren't very taxing at all. This is not killing me. Even me with my lousy arithmetic skills can sort of keep up. Here what I do is I replace the y column by these numbers. So I still have the 5, 6 column, but now I put in the minus 1, 1. You see how I just sort of insert, in this case, this in the x column, this in the y column. What does this equal? Well, 5 times 1 is 5, minus, and then minus 1 times 6 is negative 6. So you've got to be careful with these signs. 5 minus minus 6 is actually 11, not negative 1. Okay, well, there are all our players, and I can immediately report the answer. What does x equal to this system that solves this? Well, it's going to equal this value here, the dx, which is minus 15, divided by d, which is minus 8. So that's 15 over 8. That's the x answer. And the y answer would be this y value here, dy, 11, divided by d minus 8. So in fact, the answer to this system is x equals 15 over 8, y equals 11 over minus 8. And you can check your answer by plugging these back in and seeing that they actually solve both these equations. It's amazingly simple. Just compute 3 determinants, and then all of a sudden you can solve the system without multiplying through and subtracting and eliminating, blah, blah. Just very careful, 3 little steps, boom, you get the answer. Really cool. This also works for 3 by 3 systems, as you'll see next. Enjoy.